Project 3.3.3, CHUMP Arithmetic Logic Unit. So this is my breadboard circuit for the Arithmetic Logic Unit. I have 14 switches here for the inputs on the ALU. This is the pins they're connected to. And here's the 20 LEDs for the outputs on the ALU, and these are the pins that they are connected to. The A and B pins are for setting the two variables A and B, and the S pins are to set the functions. And since there are 16 total truth tables for two variables, there are 16 functions. And the F pins are the outputs for the ALU. And there's also the mode select pin right here, which can switch between arithmetic and logic modes. And there's the carry input pin, which is only used when it's in arithmetic mode to generate a carry. So as you can see here, right now it's 3, but if I generate a carry, now it's 4. For the CN+4 pin, that's a carry output, and this one is inverted on this chip, so when there is no carry, it is high, and when there is a carry, it is low. So right now, I'm in addition, and all the pins, all the A and B are set to 0, so there is no carry, so this is high. And when I do generate a carry like this, so you can see the pin turns to low. And there's also the A equals B pin, which turns on when all the outputs here are high. So as you can see, it is on when all the outputs are high, but when I change them, as you can see, it turns off because not all the outputs are high anymore. The A equals B pin also turn on when the A is equal to B in subtraction mode. So for example, here I'm on this subtraction function right here. So as you can see, A is equal to B, so the A equals B pin is on. And when I change just anything, it turns out because they're not equal anymore. And there are also the P and the G pins, which are for generating and propagating carries, but they're not very useful since I'm only using one ALU, so I didn't wire them up to any LEDs or switches. So on this paper here, I have the logic truth tables for the ALU. So I switched the A and the B pins, as are shown here on these LEDs, so that these 4 squares are the outputs of the ALU, and this is the output 3, 2, 1, and 0, and made it so that they can be easily seen through these 4 LEDs right here. So if I just go through these functions, you can see that every one of them will match. So this is function 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The functions in the CHUMP code that are operated by the ALU are the add, if zero, and subtract functions, which corresponds to the add and subtract functions on the ALU, and for the if zero function, using the subtract function on the ALU and then detecting the A equals B pin will suffice.